In this lesson, we covered depth of field in Arnold for Cinema 4D. Depth of field is the depth of the area in the render that will be in focus. So for example, in this render in the IPR, these cubes here are in focus, and as we move away from the camera, our spheres become more and more out of focus and blurrier. We have two types of depth of field: narrow depth of field and wide depth of field. Narrow depth of field is when a very small portion of our image is in focus and depth of field effect is more obvious. We can call this render in the IPR a narrow depth of field. And we have wide depth of field where a larger portion of the image is in focus and the effect is not that obvious. This is the scene we are going to be working with. We have these small cubes. They are about 10 centimeters. Also, we have this dynamic kind of simulation that's going on. Also, we have this camera, and if I go to my top view in the viewport, you can see where is my camera and where is its focus distance. If you remember from the previous lesson, we mentioned that Arnold can simply recognize native Cinema 4D camera focus distance. So I can select my camera and from the Object tab, change its focus distance or pick an object to be the focus object, or simply grab this point from the camera and change the focus distance of my camera. Now select the Arnold parameters tag that is applied to the camera, and as you can see, I have depth of field enabled. That is why we are getting depth of field in the IPR. If I uncheck enable DOF option, we would get no depth of field, and it would be like working with a pinhole lens. So the first and the most important option is aperture size, which is the radius of the camera's aperture. So the smaller the value, the wider the depth of field. And when I increase the aperture size, depth of field would be narrower and more obvious. The default value here is 0.015. Now let me show you three renders with aperture set to 0.015, 0.05 and 0.1. In the first render, which has a very small aperture size, we get this wide depth of field, and in the second render with larger aperture size of 0.015, we get narrower depth of field, and in the third render with the aperture size set to 0.1, we get a very shallow or narrow depth of field. So the larger the aperture size, the narrower the depth of field. Let me close the picture viewer for now. Let's set the aperture size to 0.1 for now. Another deciding factor when we think about depth of field is the scene scale. If I scale my scene down 10 times, we're going to have much narrower depth of field. And if I scale up my scene, let's say 10 times again, we're going to have much wider depth of field effect. Now, from the edit menu, let's choose scale project and convert 10 to 1 and hit OK. Now we have a scene that is 10 times smaller compared to before. Let me just run the dynamic scene here again. Now if I run the IPR, you can see we have much narrower or shallower depth of field when compared to the previous render when the scene was 10 times bigger. We can actually go to picture viewer and take a look at those renders here. So as you can see, compared to the previous render, even though we have the same aperture size, but because the scene is much smaller, we are getting much narrower depth of field. Let me close this window, and from the edit menu, select scale project and convert 1 to 10 this time, so we have our original scene scale back. To see the rest of the depth of field settings a bit better, let's increase our aperture size to 0.2. We have aperture blades, which is the number of blades of the polygonal aperture. 0 is considered a circle aperture. Now if I set it to something like 3, we are gonna have a triangular aperture shape. Let's take a look at the picture viewer. The aperture blade is set to 0, and in the second one it is set to 3. And you can clearly see this triangular aperture shape in the second render compared to the circular one in the first render. Let me just draw a very small render region in these out of focus areas. Aperture blade curvature controls the curvature of the polygonal aperture sides. 0 means hard straight sides, and increasing this value results in a progressively more curved edges. 1 will produce a perfect circular aperture, and negative values will create pinched aperture. So the previous render curvature was 0 and we get this straight sides. Now if I set the curvature to 0.3, we get this curved edges, and if I set it to negative 0.3, we get this pinched sides. Let's set it back to 0 for now. Aperture rotation allows you to rotate the aperture. I can rotate it as I wish, so let's set it to 45. As you can see, compared to the previous one, we have rotated the aperture and the triangles are looking another way. Let me disable this render region and set the aperture blades, aperture blade curvature, and aperture rotation to their default values. And we have aperture aspect ratio to simulate anamorphic lenses. Higher values than 1 will stretch the defocusing effect and lower values squash it. So let's set it to 0.1, 1, 2, and 4. As you can see, by increasing the ratio, we are having more stretch out the focusing areas. Let's set the ratio back to 1. Now, if I wanted to alter the focus of my camera and focus on the cubes in the back, I can simply go to the top view, select the camera, and let's change the focus distance of the camera back to here. And as you can see, we have altered the focus of our camera and the back cubes are in focus. Also, as you can see from the renders, the depth of field is pretty noisy, and the only way to clean it up is by increasing your camera or AA samples. So let's increase the camera AA samples to something like 8, and obviously if we wanted to, we can decrease the other samples, like for example our light samples or diffuse or specular samples, to compensate, but I'm gonna leave that for you. And if I compare these two final renders, you can see when we increase the AA samples from 3 to 8, we have a much cleaner result. So that is about depth of field, and I will see you in the next lesson when we discuss motion blur. See you there.